All right, guys, we are on lesson two. Lesson two has to do with ratios and what ratios are. So before we start, you've seen a ratio before. A ratio is comparing two amounts together. Okay, so a ratio is similar to a rate in the fact that you're comparing your distance traveled to your speed. Okay, but a ratio is more useful when it's not considered a rate, when it's not considered an amount over time, when it's considered comparing two quantities. Okay, so there's no time involved necessarily, or there's no distance involved. It might just be amounts of things. So we're going to get started here, and my pen shows up, and you have your new note, lesson two, ratios, or just ratio. So last class, okay, we actually created ratios. So what we did with rate and speed is that we compared two quantities together. We compared the 100 kilometers to the 2 hours, or something similar in the last lesson. Okay, and what we did is we found a unit rate. So we found out how fast he was going per hour, okay, per 1 unit of time. Our unit rates from before, we're always representing them as per 1 unit of something. Okay, so it's usually the top number divided by the bottom number, if you didn't catch that one last time. So if someone traveled 100 kilometers in 2 hours, we wrote 100 kilometers divided by 2 hours. If we reduce that, we could write 50 kilometers an hour. We could also write in a ratio of a form of 100 to 2 or 50 to 1. Okay, so instead of the equal sign, we just have a colon. Or sorry, not instead of the equal sign, instead of division sign. Division sign. Okay, so that's just a little review from last time. So we're going to get started here. A ratio, where you're going to get started, a ratio explains the relationship between two amounts. We might compare two amounts. It can also help us determine larger or equivalent amounts. So we can start with a ratio and find out if we were to increase one of them, how would the other one increase? So we can find equivalent amounts by looking at the ratio that we create. So the first one. And again, guys, if you don't get a copy down as I'm going along, just press pause and then come back once you're ready. So the first one, to make 1 liter of juice in a jug, we take 300 mils of frozen juice concentrate and add 700 mils of water. What is the ratio for frozen juice to water? All you're doing, okay, if you need to start out this way, write it out, frozen juice. And as a ratio, put in a little colon, frozen juice to water. Okay, now you're just going to substitute your values in. So we have 300 mils, or 300, we'll leave out the units for now, 300 to 700. Okay, and we can simplify that just like a fraction by dividing out a highest common factor. In this case, it's 100. So we end up with a ratio of 3 to 7. Okay, so that's just writing out what the ratio is. So the ratio of frozen juice to water is 3 to 7. Suppose we had 450 mils of frozen juice concentrate. How much water would we need? So this is what I'm talking about. Is if we're going to create equivalent ratios, or be like equivalent fractions, we take the ratio that we start with, okay, and find out how much we're multiplying by. Okay, so we can look at our ratio as 3 to 7, okay, or to make it a little bit easier for us, we'll go back up to our original one, 300 mils to 700 mils. Okay, and what we're trying to find out is if we increase that ratio to 450 mils of frozen juice concentrate, how much water would we need? This is the big question. Okay, and a ratio works the same way as a fraction. So if I were to write this out as a fraction, 300, 700, and I equate the two, 450, and I have x, we're just going to do a little bit of rearranging. So you can do it either way. Okay. One way to think about it is, what am I multiplying this 300 by to get 450? Okay, it's increasing by 150. That's half of 300, so I'm increasing this by 1.5. What I do to one side of the ratio, I have to do to the other side, 1.5. Okay, and so 700 times 1.5 ends up being, okay, 350 on 700 is 1,050 mils. Okay, so therefore we would need 1,050 mils of water. The other way I was saying just above here, if you want to do the algebraic way, okay, you can bring the x up here, okay, you bring the 300 down here, you bring the 700 up here, so that it looks like x equals 450 times 700 divided by 300. Okay, and you'll end up with the same answer. Okay, so one of two ways that you can do it. So ratios also work in representing one amount of something that is a fraction of the other. So sometimes we might be asked to answer a question where it says represent the amount of this in terms of the other thing. Okay, so when it says in terms of the other thing is going to be the one that's in your equation. Okay, so you're representing, say, x in terms of y, then you're going to have x equals something something y, and so on. So let's look at an example here. We'll follow these steps. Actually, we should highlight those ones, as those are important. So write this as a ratio, write this as a fraction. How can we represent the amount of juice we use in terms of water? Okay, so for the question above, how can we represent the amount of water we use in terms of juice? Okay, so those are the ways we would be looking at it. On the side here, I'm going to do just a quick little show. Every part of that question above, we always went juice to water. Okay, we always went juice to water. The juice to water was 3 to 7. Okay, if we want to represent, say, for example, using this question here, the amount of juice we use in terms of water, then we're going to have juice equals, and we're going to have water on this side. So to bring water on this side, okay, we can do it the shortcut way and just say we're going to bring it up on top of the fraction and multiply it with the numerator, or we can multiply by w and cross them out and multiply by w, and we still get the same thing. So when we do that, we get 3w divided by 7. So we'll just put that in another color just so you see what happens. Multiply by w, multiply by w, these cancel out, and you're left with j equals 3 over 7 times w, or 3w over 7. Okay, so let's try a real example that shows what we're talking about here. To make a Coke float, we need to use 2 parts ice cream and 5 parts Coke. If we use 400 mils of Coke, how much ice cream would make the perfect Coke float? So in this case, it's giving us the ratio, 2 parts ice cream to Coke, to 5 parts Coke. So we're going to write out, I'm going to tell you this every time, write out in words the ratio, okay, or the fraction. Ice cream to Coke, okay, equals 2 to 5. Okay, and what we're going to do, we're going to substitute in a value. Okay, so in this case, we're going to put in, if we use 400 mils of Coke, so instead of Coke, we're going to put 400. Okay, and leave everything else the same. So ice cream and 2 over 5. Okay, now we want to get ice cream by itself, so we have to use our algebra, times by 100, times by 100. Okay, and I'm just going to move this up here. move this up here. Okay, and we're going to have ice cream equals, okay, 200 over 5, okay, or 2 times 100 over 5, so 200 over 5 equals 40. So we're going to have 40. Okay, so we don't need that much ice cream, but we need a lot of Coke. And that sort of represents what our ratio looks like. If we're using 400 mils of Coke, okay, and Coke is the much bigger part of the ratio, we expect that the amount of ice cream we're using is less than half. Absolutely. Okay. Okay. Oh, my mistake. We gotta go back here. I did times 100. Okay, it's times 100 each side over here. Okay, so let me just explain what just happened. Don't know why I did that. 400, so the 400s cancel out, and we have 2 times 400, which is 800 over 5. Okay, so 800 over 5. You can pull your calculator out if you need. 800 divided by 5 equals 160. Okay, so that's much better. That makes much more sense. So I suppose that just goes to show that if you were to compare the result that you get to the ratio that you have, logically making sense, if 400 mils is our Coke, and that's represented by 5 parts, then our ice cream parts should be just less than half of that. Okay, and 160 is just less than half of 400. So therefore, you would use 160 mils of ice cream. Okay. All right, my mistake. Sorry, guys. All right, moving on to number 3. Ratios can also help explain the change in amounts by comparing them before and after. For example, last season's top line hockey stick was $300. This season it has gone down to $180 to make room for the newest stick. Write down the ratio of the last season's stick change price. Express the new price in terms of the old price. So we're going to have over here, we're going to have new price equals, and we're not sure what else is going to go over here. Something about the old price, something multiplied with the old price or divided with the old price. So let's start from the beginning. So every single time I'm going to ask you to go and put old price divided by new price. Okay, old price divided by new price. And as a fraction or a ratio, what that's going to look like, the old price is 300. The new price is 180. Okay, so what we're going to do is we have to get the new price on top and by itself. So what we're going to do is work a little bit around with this fraction here and get that new price on top. So NP for new price, NP for new price. These cancel out, and look at that. By doing that, it brings the new price up top. That's what we want. So our next line, what that looks like is 300 NP divided by 180 equals old price. Okay, now we got to get that new price by itself. Okay, so what we're going to do on this side is we're going to multiply by 180 and multiply by 180. Okay, so that these cancel out and we're left with, and I'm going to come up here. I want you to keep going down on your page, but up here, just because I'm running out of room, I'm going to have 180, and I'm going to put OP on here for old price equals 300 new price. And the last step that you're going to do is you're going to divide by 300 and divide by 300. So your final equation ends up being new price equals 180 times the old price divided by 300. Okay, so that's what we're left with. New price equals 180 old price divided by 300. Doesn't really matter what side of the equal sign the new price is on. With this one, you're not adding or subtracting, so it doesn't matter when you switch sides equal sign. You're not going to change the sign. You're just representing new price on the left side. So what the question is asking us, express the new price in terms of the old price. Okay, so therefore, the new price of a stick is 180 times the old price divided by 300. All right, next one. Milos Raonic's racket became so popular after viewers saw him use it to succeed in the most recent matches, so much so that the company increased the price of it from 225 to 350. Write the ratio down that shows the change in price. Express the new price in terms of the old price. So we're going to follow the exact same steps. I'm going to get you to write down the ratio in words. So old price, and then new price. And from after this line, I'm going to just write OP and new P. An old price was 225. It's a little bit cheaper. Now it's 350. Okay. So what we're going to do is express the new price in terms of the old price. So new price equals, we're going to get down there in a second. So again, we're going to bring up new price. Okay, so multiply by new price, multiply by new price. And we have the next line as 225 times new price divided by 350. And we have old price. Okay, we're going to multiply by 350 to get rid of that and bring it over here. So multiply by 350. So our next line equals 350 old price equals 225 times the new price. Okay, final step, divide by 225 to get that new price by itself. Divide by 225. So our final answer ends up being new price equals 350. Old price divided by 225. Okay, so it's just a step-by-step process. You're setting up two ratios. You're setting up one in words. You're setting up one with the information that you're given, and you're equating the two. Okay? All right, let's keep going here. Almost done. So a different kind of ratio is when you're working with parts and you're given a total amount. Okay, so a total amount would be the sum of everything that's given. So in this case, we have 3 parts sunflower, 5 parts raisins, 4 parts almonds, 3 parts M&Ms, and the bag is 300 grams. So how much of each ingredient is in the bag? So if we add up all these parts, okay, or 3 times, or 5 times, or 4 times, or 3 times the amount that we're given, or that we're trying to find, and we add them all together, we should get 300 grams. So the way that we're going to set this up is we're going to say 3 parts plus 5 parts plus 4 parts plus 3 parts again. And the reason why I keep using parts and not something different for each one, for each category, is because parts represent the amount of grams of the trail mix, okay, of the sunflower seeds, of the raisins, of the almonds, and so on. So that doesn't change. You're not working with two different things. You're just looking at how much in mass you're adding to the bag, okay? And each part or each term does represent sunflower seeds, but the word parts just represents grams. So if we were to add all those together, we should end up with 300 grams. Okay, so to make this a little bit more simple, we're going to go 3p plus 5p plus 4p plus 3p equals 300 grams. Okay, all together, we have 3 and 5 is 8, plus 4 is 12, plus 3 is 15. So we have 15p equals 300 grams. Okay. Want to find out how much each part is worth? Okay, so we're going to divide by 15, get the P by itself, divide by 15, P equals, and we should have 20. Okay, P equals 20 grams. So therefore, we use that 20 grams in place of the parts for each one. Okay, so we have 3 times 20. Okay, so 3 parts sunflower seeds equals 60 grams of sunflower seeds. We have 5 times 20 equals 100 grams of raisins. We have 4 times 20 equals 80 grams of almonds. And we have 3 times 20, which is 60 grams of M&Ms. Okay, we add those all together. 60 and 80 is 140, plus another 100 is 240, plus another 60 gives us 300. So this total amount of grams, total amount of mass, equals our total that we're given. Okay, so when you have a question that has parts that equal an amount, you're going to write it out like this and represent them as 3p and 5p and 4p and 3p and so on. Okay, and then it's just your algebra that we learned last unit to solve it. All right, we have one more. Okay, in a bag of Skittles there are 1 part yellow pieces, 2 part red pieces, 4 part green pieces. If there are 8 more green Skittles than red Skittles, find out how many Skittles are in the bag. Okay, this is a difficult one because it doesn't really actually give you a total. Okay, it just gives you parts. So what we're going to do, and I'm going to just use my colors here to help represent this a little bit better. It says we have 1 part yellow Skittles, or 1 part for yellow pieces. We have 2 parts for red pieces. So each parts are worth the same amount, just like the one above it represents grams. So we have a red piece, another part to represent 2 parts red pieces, and 4 parts green pieces. 4 parts green pieces. 1, 2, 3, 4. Okay. Now the question's asking us, I think that's it, 1 part, 2 part, 4 parts. If there are 8 more green Skittles than red Skittles, okay, find out how many Skittles are in the bag. So looking at our diagram now, we have to just use a little bit of measurement, okay? This here represents 8, okay? Because we have 2 parts more than red, okay? But it also says there are 8 more green Skittles than red Skittles. So up to this point, green and red are equal. Now you have 8 more green Skittles than red Skittles. So these 2 parts make up 8 Skittles. Individually, they're going to be 4 Skittles. Okay, so now we look at if each part is 4 Skittles, we can work out how much is in the rest of the bag. Okay, we have 4 yellow, so I'll come back here, we'll go 4 yellow. I'll go back to the colors again. 4 yellow, 2 red, and oh, sorry, with 4 yellow, 8 red. Change that into an 8. Nobody knows. Okay. And we have 4, 8, 12, 16 green. Okay, each one of those 4 represents 4 Skittles. So we add them all up, and we end up with 4 plus 8 is 12, plus 16 is 28 Skittles total. Therefore, dot, 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 you can write down, we have 28 Skittles in the bag. Okay, so this is considered a ratio question because you're comparing amounts just in a diagram. Okay, so you have parts compared, so it would be 1 to 2 to 4 as your parts. But because it doesn't give you an amount in the total, okay, that should be your hint to possibly draw out a diagram to compare the amounts visually. Okay, guys, that's it for this one. This is lesson 2. By the end of today, you should have copied this note down or followed along with this note. If you want to get started, you're more than welcome, but we'll give a little bit of time at the start of next class to work on these questions here. Okay, and I'm going to take a little bit of time to answer any of your questions because I know it's a bit of a big start, and some of this can be a little bit tricky sometimes. So, well done, guys, and we'll see you later.